Hello everybody. So in today's video, we're gonna take a look at two different kind of message brokers. One is RabbitMQ and one is Kafka. Please take in mind that Kafka is not a traditional message broker. It's more some kind of streaming processor to handle larger data. But without further ado, let's dive in. So let's first take a look at the basics. This is a very small diagram that shows how RabbitMQ works and basically a lot of message brokers. On the left side, we have a so-called publisher that publishes messages. On the right side, we have a consumer that consumes these messages. Keep in mind that you can have one publisher, but you can have multiple consumers on the right side. And in the middle, we have now the things that connect the publisher and the consumer. In RabbitMQ, we have a so-called exchange. Exchange is related to the publisher, and we have so-called queues, which relate to the consumer. And then we have so-called routes or bindings that map the exchanges to the queues. We will see this later, but this is the basic theory. We can bring up RabbitMQ very easily in Docker. I just say RabbitMQ. You can take a look at the README file. There's a small Docker run command that will give you RabbitMQ. And now let's take a look here. So if we take a look at RabbitMQ, one thing that comes to mind is it's very low in memory, at least in an idle state. It only consumes about 100 megabytes of RAM. And it also has a very nice admin console. So let's take a look here. We have an overview page. We can take a look at the exchanges and the queues. So as we see, currently there are no queues, and there are only the exchanges that are bound to RabbitMQ himself. So nothing of our own topics here. Now let's just start up our small application that has a producer and multiple consumers. And let's see what happens. The application starts. And what we will see now is that we suddenly have a so-called main topic here as an exchange. This is automatically created by the application. And we now also have two queues, a calendar queue and a logger queue. If we take a further look, we will see the bindings. So the calendar queue binds patient and practitioner keys to the main topic. And it's the same for the logger queue. These are created automatically at startup. So let's take a look at the code here. So we have a so-called event producer, which basically has a Rabbit template that converts and sends a message. So we see here our main topic, we see a key, and we see a data object, which is created on the fly. There is a reference ID that is passed in, and it will create some kind of data object or payload that we send as a message. On the other side, we have a consumer, and we have this here, Rabbit listener, queue binding. We have the exchange, and then now we see here main topic, exchange, bound to these keys. This is exactly what we can see here in the RabbitMQ. So if we declare these things, they are automatically created. This is a very easy annotation, and this annotation will then call a process method, and we see further things here. So our keys that are then processed are patient, create, update, and also for practitioner, create and update, and they will call another method which just logs out these things, because we could do much more, but I think it's already enough to only log these messages. What's very important, sadly, we see here the key, the binding, it somehow also narrows. So this listener only reacts to all messages which are patient and practitioner. And we have to do this ugly switch here, because what would come to one's mind immediately is, couldn't we have just multiple Rabbit listeners and one method for patient create? So basically putting the Rabbit listeners at create patient, update patient, and etc. But this is not working. So we are only allowed to have this one Rabbit listener here, and then we have to delegate everything programmatically. So let's see this thing in action. To see this thing in action, we can go to our web page and yeah, we can just, I reload the page and I click here. Nothing is, we can see nothing here, but we see here now, oh, a patient is created. Or I can say update patient, and then a patient is updated with a unique ID. The same goes for create petitioner and also for update petitioner. So this is mostly just for the sake of this demo. We have a very easy HTML page. So with some buttons we can click and to create events and to consume events. This is done by a simple controller, Spring MVC controller. So we have a get mapping for create patient. We have a get mapping for update patient. This will create the REST methods that we see and also WebSocket methods. This is something we will see later. And then it will just basically call this logic, and this will call the event producer we have seen earlier, which has two different implementations. And this will create the message again. Main topic, the key patient create update or practitioner create update, and then it has a payload which currently only consists of the reference ID, just to demo this. What's also important is if you want to provide a payload, so this is this object here, event data, there is one additional thing you have to do. You have to create a bean, which is called JSON converter, and return a new JSON message converter. Otherwise, you will get an exception. Okay, that's so much for RabbitMQ. Now let's dive into the next topic. So next up is Kafka. Please keep in mind, as I told earlier, Kafka is not a message broker per se, but it's more like a stream-oriented processing. It's made for things like processing a lot of data, while RabbitMQ is just more for simple messages. We can also bring our Kafka via Docker run. Unless it's a little bit more complicated, it looks like this. You can also find this in the README. It brings up two things. It brings up one instance of Kafka and also the so-called zookeeper instance. So Kafka is running. What we also now need to do, we have a profile here where we can switch our Spring Boot application to either use Rabbit or Kafka. So I say, I now want Kafka, which is very nice that I can switch this over. I run the application. Starting. And it connects to Kafka, which we see here. Close my RabbitMQ, I reload my page, and it's the same page because it's the same application. And if I click here, we should get the same results. Honestly, it looks exactly the same, but this time we are not leveraging RabbitMQ, we are leveraging Kafka. Unfortunately, Kafka does not have a UI directly. You have to bring in another UI. It's not the same as with RabbitMQ. Also, if we take a look at the resource usage, Kafka in idle state already consumes 500 megabytes in contrast to RabbitMQ. And there is also the so-called zookeeper instance, which also consumes another 100 up to 150 megabytes of RAM. Why is that? Because both of these are Java applications, while RabbitMQ is written in Erlang, which is similar to C. And Java applications, that is unfortunately what we already know. If you don't have native images, they already in an idle state consume a lot of memory. But nevertheless, if there is the demand to process a lot of data, Kafka could be the better choice. Please keep in mind, usually there is not one Kafka instance running, but you have multiple Kafka instances running. Usually as simple it could be as Kafka 1, 2, 3. And this works if we take a look at our application here. we have the so-called bootstrap service endpoint here, which is localhost 1992 in my simple case. But if this is running inside a cluster, you would have something like Kafka 1, Kafka 2. And what will automatically happen is that there is some kind of round-robin mechanism which calls the brokers one by one. So there is nothing you have to do on your own. But for our demo, it's enough to have one instance running. What's also important, similar to RabbitMQ, if we want to create events with data, we have to set a serializer and a deserializer. Again, the JSON deserializer, this is something we can do with properties in the case of Kafka. Very similar to what we saw with RabbitMQ and the Jackson message converter. Code-wise, it's very similar. We have our event producer Rabbit, and we also have our event producer Kafka, which implements from the same event producer interface with the two implementations. And instead of a Rabbit template, we have a Kafka template. And mostly it works the same. We say send some kind of topic, which is an ID here, a key, and then our event data will be sent over. What's also important, so that the topics get created inside of Kafka, similar to the queues we have in RabbitMQ, we have to say add b new topic and then create this main topic. So that's the producer, which is specific to Kafka. And on the consumer side, we just have another annotation. It's not the Rabbit listener, but it's the Kafka listener annotation that gets an ID, which is the queue name here. Also, we don't have queues, so this is just to have a unique ID here. And also topic is the main topic that we sent earlier. Other than that, it will delegate to the same process method as with RabbitMQ, and it will do the same thing. So what we see here with this very nice Spring abstraction, it's possible to have very similar code for two totally different kind of brokers with RabbitMQ and Kafka, and they work the same. Okay, that's so much for Kafka. One more thing to go. So now we've taken a look at the backend, and we see that we have basically a publisher and a consumer, which is the pattern of publish and subscribe. And this is something we have on the backend. And on the front end side, of course, we can just have a REST method to trigger these events. But wouldn't it be nicer to have also something like publish and subscribe on the front end side? And this is something we can do with so-called WebSockets. For WebSockets to work, we need a simple configuration class that looks like this. We have to say enable WebSocket message broker, and then we have to register an endpoint, which is just /WebSocket. You can name it whatever you want. You just have to deal with it on the front end side. In the controller, where we already have our host mapping and get mapping for our REST endpoints, again, these work. To get something similar with WebSockets, we can use another annotation, which is called message mapping. Please keep in mind that we have also request mapping and message mapping at the class level here. So the complete path consists of events / and then create patient in both ways. So with message mapping, we just can react to WebSockets, the same as with REST endpoints with get mapping. And we can also send back message with another annotation, which is called send to. For send to, it's again, we can just have some kind of topic, and I chose to have a generic topic, which is always public. If you want to see how this works in JavaScript on the front-end side, it works like this. So we first have to connect to our socket. So we say new sock.js / WebSocket. Then we are using Stomp. This is an abstraction that was created by the Spring people here. And we can then subscribe to our public one way. And on the other way, we can have our create patient triggered, which sends events, which goes from the HTML. So our HTML will either create a patient via REST call, href, or it can also on-click create patient, which will basically call this JavaScript, which will then do a WebSocket publish. And on the other side, we can subscribe to this. Let's see that in action. So we will see here in Chrome, when we have our console open, we see that there is something going on here. And every time now I click on my socket here, we see patient updated, get socket patient updated, or practitioner created, got socket mesh practitioner created. And this is the way it works. Again, we subscribe to our public channel that is sent back by our controller, and we send messages via our Stomp client send methods. And this way we can have bidirectional send and also subscribe to these messages. One more thing, if you want to have things working behind a reverse proxy like Nginx, there is some additional stuff you really need to do. So you have to set some mumbo jumbo here, which you can look up here. And also, usually, like in this use case, if we have a sub URL in our reverse proxy, like dispatcher, it's not possible, unfortunately, for SOC.js to work with relative endpoints. So if you do something like this, or something like this, a lot of bullshit will happen. This is not working. You can only have relative URLs. And the easiest way to sneak in the dispatcher sub URL was to have a subfilter that rewrites our JavaScript file, and then it's working. And this way, it's working inside our reverse proxy with the reverse proxy sub URL, but it's also possible to just bootstrap the application from your IDE, and this will also work. Okay, everyone, that's it for today's video. Thank you so much for joining, and I hope to see you in the next video. See you!